Welcome students in the subject of engineering materials and metallurgy. I am Professor A.P. Godke, Assistant Professor in Department of Mechanical Engineering of S&D College of Engineering and Research Center, Babulgaon, Yeola. Today we learn the subject engineering materials and metallurgy, which is present in the course of AC Mechanical 2019 pattern. So we'll see the first unit of our subject, that is the engineering materials and metallurgy, in which we are going to see the various material properties related with the engineering materials. So the classification of engineering material properties are shown in this diagram. So each and every material, यहाँ सांस लो कस कर recording हुए So the classification of material property is shown in the figure here. So various material properties are classified here. The first material property is a physical property. Second is the magnetic property. Third property of material is a chemical property. Fourth important property is a technological property. Next is the electrical properties. Next important property is optical properties, thermal properties, and last, which is very highly important property, is a mechanical property. So these are the number of properties that can be sustained by a various materials or solids. Now we will see one by one the detailed study of each and every property of the materials. So first property is a physical property. So physical property is nothing but the property of material which is related with the density, size and shape of the material, gravity of the material, and porosity of the material. So the physical property is related with these four types of sub properties, which are density of materials, size and shape of the material, specific gravity of the materials, and porosity of the materials. Now we will see one by one the physical property of materials. The first is the density of material. So what is meant by density? Density is one of the most fundamental physical property of any material. The density of material is defined as mass per unit volume. Okay, this is the definition of density of material. Whenever we take the ratio of mass per unit volume for a particular material, it will be called as a density of that material. It is also defined as the ratio of mass to volume of material. It is also defined as the ratio of mass to volume of material. Okay. Again, same, that is the ratio of mass and volume. Next, the symbolic representation of density is denoted by rho. Okay, so that is the it is denoted by a letter rho. Then the SI unit or unit of the density is kg per meter cube. So that is the SI unit of the density, kg per meter cube. So kg is the unit for mass and meter cube is the unit for volume. So that is the kg per meter cube is the unit for density, that is a mass per unit volume. Now next one is the density. It is an important in many calculations because most designs are limited by either size or weight. Means any material can be represented with respect to size or its weight, and it is directly related with the density. Means depending on the density, the size as well as weight of the material is going to change. So this is the first important property of the material called as a density. Now we will see one example of density, how densities can be defined and how it can be worked for any type of a material.
This is the example we left out in the previous video. If we drop a piece of balsa wood and a metal pin of the same mass into the water, what will happen? Will both of them float or will both of them sink? Or one stays afloat and one sinks? Just by intuition, we can say that the wooden block will float and the metal pin will sink. But if they're of the same mass, why does that happen? Shouldn't both float because of the buoyant force? This happens because of the difference in their densities. But what's density? Look at these two parking lots of the same size. One has 3 cars and the other has many cars. Which one is more dense? This one, correct? Yes. Now look at these two forests. Which one is more dense with trees? Clearly, it's this one. So in the same given amount of space, if there are more things, we say that it's denser. Density is simply the measure of how compact the mass in a substance or object is. If we have to go by its scientific definition, we would say that it's mass per unit volume. In short, it tells us how much mass exists in a given volume. The unit of density is kilogram per meter cubed. Mass is in kilograms and volume in meter cubed. Coming back to our example, why did the wood float and the pin sink? The wood floated on water because the density of the wood is lesser than the density of water. Hence, the upthrust of water on the wood is greater than the weight of the wood. Hence, it floated. But the density of a metal pin is more than the density of water. Though it looks tiny, there's more mass per unit volume within it as compared to water. Hence, the upthrust of water on the pin is less than the weight of the pin. So what can we conclude? If the density of an object is lesser than the density of the liquid, then it will float. And if the density of an object is more than the density of the liquid, then it will sink. We'll understand the Archimedes principle in the next video.
Okay, so from this you can get the clear idea about what is the density of material. So it is the mass per unit volume. Ratio of mass and volume is called as a density. Next important physical property of the material is the size and shape. So in that the dimension of any material or metal reflects the shape and size of the material. Length, width, height, depth, etc. Means what? Any dimension in the form of length, width, height, and depth will denote the size and shape of the material. Also, it determines the specified rectangular, circular, spherical, or any other cross section of the or section of the material. Means the size and shape is also one type of a physical property of the material. Third one is the specific gravity of materials. It is defined as the ratio of density of material with respect to the density of reference material or substance. So this is the simple definition of specific gravity of material. It is defined as the ratio of density of material with respect to density of reference material or substance. So it does not have any unit. So specific gravity, it is the unitless quantity. Okay, because we are considering both the density of material, means kg per meter cube and kg per meter cube will get cancelled and it will be become unitless quantity. So here we consider at denominator density of material and at numerator density of reference material, means it becomes a unitless quantity. Sometimes it is also called as a relative density. Specific gravity, there is also another name to the specific gravity called as a relative density. For gravity calculation, water is always considered as a reference surface. Means whenever we are finding out the specific gravity of any material, then we are consider the water as a reference substance. Now we will see one example for specific gravity of material.
Specific gravity of any substance is the ratio of the density of that substance to the density of a reference substance. We usually take water as the reference substance. But as we know, density of water varies with its temperature. So we take densest water, which is at the temperature of 4 degrees. So if a substance has lower density than water, which means substance is lighter than water, then the ratio specific gravity will become less than 1 because the numerator is smaller than the denominator. And similarly, if density of that substance is higher than water, which means substance is heavier than water, then specific gravity value will become greater than 1. So by simply looking at the value of specific gravity, we can estimate the weight of that substance. If specific gravity has the value less than 1, then substance is lighter than water. And if it is greater than 1, then substance is heavier than water. And the value of weight of any substance is specific gravity of that substance times the weight of water. In the case of solids, that substance becomes the solids present in the soil sample. So specific gravity of solids, which is denoted by G or GS, can be defined as the ratio of the unit weight of solids to the unit weight of water, which is weight of solids of a given volume to the weight of equivalent volume of water at 4 degrees centigrade. For most of the soils, the value of specific gravity lies between 2.65 to 2.80. In a unit volume, coarse grained soils, as they have large particle size, have less mass and more voids, while in the same volume, fine grained soils have more mass and less voids. So, by definition, we can see that coarse grained soils will have lower value of specific gravity than fine grained soils. Similarly, if organic matter is present in the soil, then because of organic matter being less dense than the soil, weight of soil mass will become less and the value of specific gravity will become comparatively lesser than the soil which doesn't have organic matter into it. Soils with heavier elements like iron or mica will have higher weight in a given volume, hence will have higher value of specific gravity. These are the specific gravity values of different soils. Thank you.
So in this way, we can clearly define the specific gravity of the material. Means the ratio of density of material to the density of reference material or substance. So it is unitless quantity. So either it will be less than 1 or it will be greater than 1. Okay. Next important property, physical property of material is the porosity of material. So the definition of porosity of the material is nothing but when material is in melting condition, it contains some dissolved gases within the material. When material is solidified, these gases gets evaporate and leave behind voids. So that voids space is called as a porosity of the material. So porosity of material represent quantity of voids in the materials. Okay, so this is the simplest definition of porosity of the material. So there will be a void space or voids are formed inside the material whenever material gets solidifies, and that number of voids or quantity of voids is called as a porosity of the material. Now we will see the example of porosity of the material.
Hello friends, welcome to my channel Civil Engineering Forum. Today we are going to learn something about physical property of a material known as porosity. So at first we'll go with the definition. Porosity may be defined as percentage voids in total volume of a specimen, and it is symbolized by small n. So now if we consider two different materials with different voids, the material on the left hand side has more voids while on the right hand side has comparatively less voids. So depending upon the percentage voids, the left one has more porosity and comparatively the right one has less porosity. Or we can even say that material on the left hand side is more porous as compared to that on the right one. Now if we talk about the formula and unit, the formula is porosity is equal to volume of voids upon volume of material. And symbolically it is represented by small n is equal to VV by V. That is, volume of voids is abbreviated by VV and volume of material is abbreviated by capital V. And as it is the ratio of volume, it is unitless, or we can say it is constant. So ultimately we can say that more is the porosity, more will be the percentage voids. That will be for a particular material. So friends, this was all about physical property of material porosity, and thank you for watching.
So in this way, the porosity of the material can be defined. So this is all about the physical properties of the materials. So what we learn, what is the density of materials? What is the shape and size of the materials? What is specific gravity of materials? And what is the porosity of materials? So all these four are considered as a physical property of the material. So this is the first important property of the material from the classification of property of the materials. Second one is the chemical properties of the material. Okay. So what do you mean by chemical properties of the material? So the chemical properties related to the changes in the chemical composition of material because it interacts with other substance. Chemical properties of engineering materials are needed because most of the materials, when they come in contact with other substances, can react to form a new material. So it is the deterioration of material by chemical reaction with its environment. Okay, so that's why the chemical property of any materials are important. Second, it cannot be observed without changing chemical composition of substances. The chemical property include pH, production of salt, when an acid reacts with the metal, or unique color change in the chemical reaction. Okay, so whenever there is a change in the material, the chemical composition or chemical properties are going to change. So this is the second important property of the material. Now we will see one example of chemical property of the materials.
We saw that elements cannot be clearly classified into metals and non-metals based on their physical properties. Will chemical properties help? Let's understand chemical properties of metals first. When we're looking at chemical properties of metals, there are a few things we will look at. We will see what happens when metals are burnt in air, when metals react with water, when metals react with acids, and lastly, when metals react with solutions of other metal salts. Now, in all these four categories, there's just one simple thing we will do. We will look at how reactive the metals are. If the metals react easily, may it be with oxygen or air or anything else, we say that they are more reactive. When it's more difficult for them to react, we say that they are less reactive. Let's focus on the first category, metals burnt in air. The most important points to note here is that almost all metals react with oxygen to form metal oxides. These metal oxides that are formed are usually basic, but they can also be amphoteric. What do we mean by amphoteric? Metal oxides which may show acidic as well as basic behaviors are known as amphoteric oxides. Most metal oxides are insoluble in water, but some may also dissolve to form alkalis. Okay, so metal oxides being formed in one thing, but do all metals react with oxygen at the same rate? Not really. Different metals show different levels of reactivity towards oxygen. Alkali metals such as sodium and potassium react vigorously with oxygen. In fact, they react even if they're just kept in the open, that is, at room temperature. They don't even need fire to ignite the reaction. What about the other metals? Metals such as magnesium, aluminium, zinc, and lead also react with oxygen at room temperature, but they react a bit differently. When they react with oxygen, their surfaces get covered with a thin protective layer of oxide. This layer protects the inner part from being oxidized. What about iron? Iron doesn't burn on heating, but iron fillings burn vigorously after being heated. And which metals do we have at the end of the spectrum? Yes, silver and gold.